Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. So in this session we will continue definite integrals. We have already covered a lot of properties of definite integrals. So today I'm going to discuss nth reduction formulae, and if time allows then I'll continue use a summation of series using integration. All right, so I'll cover first reduction formulae in detail. All right, so let's do it. So here's my profile. So let me start with my introduction. So I'm Jeetendra Dixit. I did my BTech from IIT Kanpur, and I've been mentoring IIT-JEE aspirants for last 11 years. I've worked with various national level institutes in Delhi, Mumbai, and Lucknow, and I teach mathematics. So before beginning, let me also tell you about the platform, Unacademy platform. So you can subscribe for Unacademy Plus and Iconic subscription. So there are two subscriptions which Unacademy is offering. So I'll tell you about both. So for what is this Plus subscription? If you get Plus subscription, then you can access daily live classes of all the JEE educators and their recorded sessions as well. Right? Let me check my voice. Right. So live test and quizzes will also be accessible to you. And if you're not taking any subscription, then you can attend special classes. Special classes are completely free. So special classes unlimited. Unlimited special classes you can attend. Just download the application and start watching these special classes. So every day, many educators are taking these special classes for free, and you can attend. There are free courses as well, which educators launch. Okay, so many things which you can watch, which you can get without getting the subscription. So if you are not taking the subscription, then go and see all these things. You will be familiar with the platform. Also you will be noticing how interactive this platform is. All right, so and if you're taking the Plus subscription, then you'll see the whatever the courses you want to attend, you'll see it is well all courses are very well structured. That means everything is pre-planned, so you can see the schedule of all the upcoming lectures in well advance. These are the subscription charges. So for 1 year, you can subscribe 1, 3, 6, 12, and 24 months. For 12 months, you'll have to pay this much, 38,500, and for 24 months, it is 56,000. And after 10% discount, these two will be basically of price 34,650 and 50,400. Okay, so you can use my code Jeet1 to get this 10% discount. Now this is about the iconic subscription. What is this iconic subscription? Let me tell you. There's a new feature which we have added to the platform. In this, you get all the benefits of Plus, which I was telling you just now. Okay, so all those things you can obviously avail. Apart from that, you will get a personal coach who will guide you throughout your preparation for top exams like IIT-JEE Advanced, Main, BITS, all state level exams. All right. So throughout your top exams, you will get a personal coach who will keep guiding you. All test analysis will be personalized manner. Personalized means what are the improvements of area, what is the time management, what should be the approach in exam. Everything should be will be done in a personalized manner. Study planner will be customized to you. All right, you can see study plan, and so this is a personal, basically everything will be in a personal manner. All right, so you'll get this personal attention if you take iconic subscription. So this is a new feature we have added, and this is seriously iconic. So now you can see this 12 months price for iconic is not much. It is just 56,000, and even if you get 10% discount using my code, then it will have to be only 50,000. Okay, that means around 3 4,667 per month, right? And if you are taking 12 years subscription, then after 10% discount you'll have to pay 77,400, which is basically 3,583 only per month. All right, so very, very low. And in this you're getting personal care in terms of your preparation, strategy, planning, analysis, everything. All right, so this was Iconic subscription. I hope things are clear. You can download this Unacademy's learning app from Play Store, and after downloading you can subscribe. So now let's begin integral calculus. Okay, so as I told you, we are going into the reduction formula today. Reduction formula. What happens? See, suppose of integration. So I'll tell you reduction formula. What is reduction formula? Whenever you have a some function in terms of n, okay, and you can't find the value, but you can form a relation of fn with f of n minus 1 or f of n minus 2, where n is an integer. All right, n is an integer. It might be natural number, it might be whole number. All right, so if you can form a relation between f of n and f of n minus 1, that means like nth term or n minus 1th term. It's like if you're integrating see, if you're integrating sine raised to n. Okay, so now you can see power is n. Power is not 2, power is not 3, because if it is 2 or 3 you can integrate it. So it is n. N means it can be anything. It can be 100, it can be 200. All right, so obviously you can integrate it directly. So I will write it in. Because of this n, I will write it in or fn, whatever. So now you can't find in directly, but you can form in relation of in and in minus 1 easily. So the relation you form between in and in minus 1, that is called reduction formula for this particular integral. Okay, so every such integral in which power is you are putting n power to some variable. Okay, so because of that you won't be integrated, you won't be able to find the antiderivative directly. So you first form the reduction formula, and using that reduction formula you keep on decreasing the power. I mean, keep on integrating. Using that reduction formula you can integrate it easily. All right, you can reach to the integral where n is very low, n is like 1 or 0, if 0 is allowed. So let me form the reduction formula for this one. For example is, so how to form reduction formula? I mean, you need to apply by parts or whatever the way of integration you do, you can apply that. There's no restriction in this. So how to start? You have two ways to integrate it. You can write 1 into sine raised to nx, all right, or sine x into sine raised to n minus 1x, because you don't know the integral of sine raised to nx. So by taking 1, if I start, then after integrating 1 I'll get x, so algebraic function will appear, and then I won't be able to write that next integral in terms of in minus 1 or in minus 2 because of that x. So it's not advisable to take this one, but this will be okay, because you will get sine x in derivative or antiderivative of sine x is cos x. All right, and if you are differentiating this, then again you'll get a cos x, so you get 2 cos x, and cos square you can write in terms of sine square. So again the whole expression can be brought in terms of sine, which can be written as either in minus 1 or in plus 1. Okay, so we'll see what it becomes, or in minus 2 might be. So it's starting like this. Just separate one sine from this sine raised to n and write sine x raised to n minus 1 now dx, and then apply by parts. So the sine x, integral of sine x is, you'll integrate sine x and differentiate this. Sine x raised to n minus 1 into differentiation of, sorry, integral of sine x is minus cos x. Right, and then minus integral of sine x is minus cos x, and differentiation of sine raised to n minus 1 is n minus 1 sine raised to n minus 2x into differentiation of sine x is cos x dx. All right, like this. So this is what we are getting. Then this minus minus will become plus. All right, this minus minus, and write this minus because that's an indefinite integral, so there's no limit. Indefinite integral, generally this terms vanishes. All right, when you put the limits, like it is 0 to pi by 2, so if you put 0 to pi by 2, then this will become extremely easy. So first let me do indefinite, then I'll tell you the definite one also. for this particular, right? So I'll write cos x as it is, and then sin x raised to n minus 1 plus, now you can see this is n minus 1 is outside, this cos and this cos will become cos square, which you can write 1 minus sin square x, all right, and multiply to sin raised to n minus 2x dx. Then it will be minus of cos x sin x raised to n minus 1 plus, you multiply this n minus 1. Okay, so first integral will be sin raised to n minus 2x dx, which is nothing but in minus 2. So I'm writing that in minus 2. I'm writing this integral sin raised to n minus 2x dx as in minus 2, right? Obviously, because power is n minus 2, so it is in minus 2 comparing with this. And the second integral sin square into sin raised to n minus 2 will become again sin raised to n. So that is in only, and n minus 1 is outside, so multiply in minus 1 also. So n minus 1 in, all right? So this, and then you can write the answer. So just separate this in, all right? So it is going to be n times of n minus 1 plus 1 is n times of in is equal to n minus 1 times of in minus 2 plus this, minus this term also, minus of cos x into sin x raised to n minus 1. This will also be there. So this is going to be the answer, right? This is going to be the answer. Now see, if it would have been definite integral, then it will be slightly easier. See, I'll tell you. This is sin raised to nx, all right? Sin raised to nx dx, 0 to pi by 2, 0 to pi by 2. So if I apply the formula, this is same as integral 0 to pi by 2. If you apply King's rule, cos raised to nx dx also, both are same, right? Both are equal, 0 to pi by 2, sin raised to nx dx is equal to 0 to pi by 2. You can apply King's rule, 0 to a fx dx is equal to 0 to f of a minus x dx, right? You'll get cos raised to nx, both are same. And this again apply the by parts using the same thing, like writing this, the same integral, indefinite integration will remain same, sin x. You just need to put the limits now, all right? So I'll write it quickly. It is exactly same. So if you apply the same by parts, then it is going to be sin raised to n minus 1x into minus cos x. So minus I'll write outside, cos x, and 0 to pi by 2 plus this became cos square, and we are getting n minus 1 also, and sin raised to n minus 2 x dx, right? We're getting this 0 to pi by 2. Now see, this part will vanish, because if you put pi by 2, this cos will become 0. If you put 0, this sin will become 0, right? So this part is 0. So what is left now? The only thing which is left now, again you will do the same thing. Cos square can be written as 1 minus sin square if you multiply. So you'll get n minus 1 in minus 2 minus this in minus 1 times of in. Okay, so now you can see this reduction formula is easy compared to what you have done in definite integration, right? So mostly it is very useful to use reduction formula in definite integrals, and they ask in definite only, but sometimes they ask in indefinite also, because that was not lengthy. The previous example was not very lengthy. So it is n times of in is equal to n minus 1 times of in minus 2. Now see how to find the value using this reduction formula. I'll tell you. So this is the reduction formula finally. Okay. So this is in minus 2. So in can be related with in minus 2. So using that, say you need I10. That means that is your version, 0 to pi by 2 sin raised to nx dx. Okay. So using this, you can write the answer n minus, so just remember this formula. So if you want to use I10, the I10 will be 9 upon 10, then 8 upon, okay, 9 upon 10. We are just forming the answer. So that will be I8. Then you put the value of I8. So that is going to be, now put n is equal to 8 in this. So 9 upon 10 into, if you put 8, 7 upon 8 I6. Now you can see this number will keep decreasing like this. 9, 7, and then 5 will come, then 3 will come. So you can write the answer directly. 9 into 9 into 7 into 5 into 3 into, all right, and then you can use 1, okay, because if 7 is there, then this will be I naught, all right. And even if you want, if n is given greater than equal to 1, then you can stop at 3 also, but in this case you can use I naught also, okay. I naught will give you the correct value. So I1 divided by, in denominator it is going to be 10 into 8, this 8, and then it will be 6 and then 4 and then 2, and this is going to be I naught, and I naught, as you can see, I naught you can find here easily. Just put n is equal to 0, it is 1, and so I naught is going to be pi by 2. We are indicating 1. So put the value I naught and you'll get the answer. So this is also called Wally's formula, all right. So you can find the values of sine raised to n easily, sine raised to 10, sine raised to 11. If it is odd, then in numerator numbers will be like 10, 8, 7, 10, 8, 6, 5, 4, 4, 2, like this. Then and finally it will end at I1, okay, I1. So you can integrate sine x, that is 1. So this was the reduction formula for sine raised to nx. Now let me tell you one more example. If you have in is equal to integral 0 to infinity x raised to n e raised to minus x dx. Okay, let's do this. We need to find in only in this case. So apply the formula. You can differentiate this, you can integrate this, right? So x raised to n as it is, e raised to minus x with minus sign, 0 to infinity, minus integral 0 to infinity x raised to n can be written as n times of x raised to n minus 1, e raised to minus x, e raised to minus x, and minus minus plus dx. All right. So this limit is going to be 0 because x raised to n upon e raised to x approaching to infinity is approaches to 0, right? And if you put 0, then this term will become 0, 0 into 1 is 0. So this is 0 only, and this is in minus 1. So it's a very simple one, right? So in is equal to n times of in minus 1. We have got the reduction formula, and then you can write the answer. So you can write in is equal to n times of in minus 1. Then n into in minus 1 can be written as n minus 1 times of in minus 2. In minus 2 can be written as n into n minus 1 into in minus 2 can be written as n minus 2 times of in minus 3, and keep decreasing it. So finally you will write n into n minus 1 into n minus 2 into so on up to 2 into I1, right? So I1 or maybe I naught you can take. Okay, so let's take I1, okay, and then we can check I naught also. So that depends whether the question gives you n greater than equal to 0 or n greater than equal to 1, okay. So there you can stop. Like n is given greater than equal to 1, so that means you need to stop at I1. So I'm stopping at I1. It is n factorial into I1, okay. Now let's find I1. So I1 is basically 0 to infinity x e raised to minus x. You can integrate it easily. Yes, minus x e raised to minus x, 0 to infinity, and plus again integral of e raised to minus x is minus of e raised to minus x, 0 to infinity. So this we know is 0, and if you put 0 infinity in this, it is going to be 0, and if you put 0, it is going to be minus 1. So it is plus 1, right? Finally. So it is nothing but n factorial, right? That means I3 is 3 factorial, I5 is 5 factorial, I6 is 6 factorial. In that way, you can find the value of this integral easily. So I hope you're getting it. So this was the reduction formula as well as the answer. Now let's do some. Let me give you one more example. This is a very good example. In is equal to 0 to pi sine nx divided by sine x, all right, dx. Here is this. This is the example. See how to start it. We need to make the, in this, applying by parts is not going to be easy, because which will be a first function and which is a second function, you try it. So you won't be able to find that, because finally in minus 1 should be in terms of sine of n minus 1 x, or sine n minus 2x in minus 2. So that is not going to be easy, all right. So what we do in this case, we already choose in minus 1 and we add and subtract with in to simplify this expression, whether we can integrate it or not. So if I take in minus 1, it is going to be 0 to pi sine of n minus 1x divided by sine x. Let's see if you add these two in and in minus 2 or subtract, then will they make an expression which is integrable? So they will make this expression sine of nx plus sine of n minus 1x divided by sine x. So first of all, if you apply sine c plus sine d, then that this sine x must get cancelled. That should be your primary aim. So if you apply sine c plus sine d, that is 2 sine c plus d by 2. So if you apply c plus d by 2, then it will be certainly in terms of n. And if you apply c minus d by 2, so you can see c minus d is basically x, and by 2, so that will be x by 2, and it will come in cos also. So first of all, to change that cos to sine, you need to subtract these two, okay, minus. If you subtract, then you'll get cos c plus d by 2, 2 cos c plus d by 2, so that is not our concern. And then sine c minus d by 2, so that in that way you'll get sine x by 2, but you need sine x. So what to do? That the difference of angle should be 2x. That means you should start with n minus 2, not n minus 1, but you should start with n minus 2, right? So in minus 2 and minus 2, all right. Now it will work perfectly. If you apply the formula, this is going to be 2 cos c plus d, so that is 2 n minus 2, so n minus 1 into x into sine x, all right, divided by sine x. This sine x will get cancelled, so you'll get this, all right. Now you can apply this. So this is the way to do it. This is a very, very important example. So in minus 2 is equal to 0 to pi sine of nx minus sine of n minus 2x, all right, divided by sine of x dx. And after this, apply this formula. We have already done the calculation, so directly write it. So you are going to get 0 to pi 2 times of cos of n minus 1 into x dx, all right. Integrate it. 0 to pi cos of n minus 1, it is going to be coming out to be 0, because if you integrate it, is going to be sine of n minus 1 x divided by n minus 1, 0 to pi 2 times, if you put pi, it is 0. If you put 0, then it is also 0, so 0. That means your answer is very simple in this case. In is equal to in minus 2, all right. Like this. That means if you have even or odd, accordingly it will end at 1 or 2 or 0, you can say, right. So n is even. If n is even, then what is your answer? In is equal to in minus 2 is equal to in minus 4. All these numbers are even numbers now, right? So it will be I2 and then I naught. So whether you calculate I2 or you calculate I naught, they must be same. So if you calculate I naught, then it is going to be 0 actually. You can clearly see it is going to be 0 if you put n is equal to 0. But let's check I2 also, because n is not given, so I'm assuming that n is 0 is also valid in this case. Okay, so n is 0 and 0 is valid in this case. It should be given in the question. So it will be given if it is valid, all right. So if I put, okay, let's see n is a natural number, then I can't go up to 0. So So let's check I2. So I2 is 0 to I2 is 0 to pi sine 2x divided by sine x dx. So it is nothing but 2 integral 0 to pi cos x. And you know integral of cos x 0 to pi is nothing but 0. This area positive and this area negative. So it is going to be 0. So yes, it's 0 only. So this answer is 0. If n is even, this answer is going to be 0. If n is odd, then in is equal to in minus 2 is equal to in minus 4 and so on up to I1. All right, and I1 you can calculate is nothing but these two will cancel out. I1 is basically 0 to pi 1 dx. All right, so it is nothing but pi. Okay, so in this case this all these terms are equal and equal to pi. Wait a minute. Okay, so these were some examples of reduction formulae. Now we will continue our practice session, today's practice session. Let me check my voice once again. I hope it is. Yeah, perfect. Okay, all right. So now let's do some examples. So here is a first question which we have already done. So we know what is the answer of this. With this we just did it. We were doing 0 to pi by 2. Now it is 0 to pi. So here is the example. Yeah, we did it for 0 to pi by 2. Now you need to do it for 0 to pi. So it's almost same. Try this one. Apply by parts in this. Only the changes in limits only. Everything is same. All right, so let me do it. So we have already done it, right? In is equal to 0 to pi. So we need to write sine x into sine raised to n minus 1x dx and apply by parts. So it is going to be just integrate sine and differentiate sine raised to n minus 1. So it is going to be cos x with minus sine into sine raised to n minus 1x as it is, all right? 0 to pi minus, so plus you can put, and it is going to be cos x into, again differentiating this will get n minus 1 sine raised to n minus 2x into differentiation of sine x is cos x again, so cos square dx 0 to pi, and this is going to be 0, right? If you put pi it will be 0, if you put 0 then again it is going to be 0, all right? Now this cos square can be written as 1 minus sine square, so n minus 1, it is 0 to pi 1 minus sine square. So complete procedure is same, the only difference is in limits as I told you, right? Now it is going to be n minus 1 into first term you'll get is nothing but in minus 1 minus second term you'll get is nothing but in, all right? So in is equal to n times of in is equal to n minus 1 times of I n minus 1, all right? So now you can see in can be written as n minus 1 times of in minus 1 divided by n. So at least you can now tell us whether it is decreasing or increasing sequence, because he's asking whether the sequence is decreasing or increasing. So in minus 1, if you see which one is greater, in or in minus 1, so which one is greater? See which one is greater, we can answer using this, as well as you can answer using this also, using the geometrical interpretation. So first let's answer using geometrical interpretation. This is the area, this is the graph of sine, this is the graph of sine square, right? And if you keep increasing the power, graph will decrease, come down, right? Because values. So obviously area will decrease. So it's a decreasing sequence, of course, all right? And using this also you can see in minus 1, in minus 1. This was in minus 2, I'm sorry, in minus 2. This was in minus 2, all right? Let me check here. There's in minus 2, not in. So this is in minus 2, okay? So you can find in minus 2 as well, right? You can see in minus 2 and okay, so this A is the correct option. In is a decreasing sequence, right? And in is irrational when n is even. N is even. So even for even, what you can do is in you can write is n minus 1 by n, then n minus 3 upon. If you put any in minus 2, that will be n minus 3 upon n minus 2, in minus 4, and then keep decreasing it, in minus 5 upon n minus 4. Okay, just reduce these numbers by 2. Okay, just keep reducing these numbers by 2, and because n is even, so these numbers will be odd numbers, right? Odd numbers, so they will end at 3 and 1, and number in denominator is 1 more than this, right? If it is n minus 1, denominator is n. If it is n minus 3, denominator is n minus 2. So if it is 1, denominator will be 2. If it is 3, denominator will be 4, all right? And then this will be I1. This is you have raised to 1, and when you are using 1, this will be 0, I naught. Okay, so it is going to be I naught. So what is your I naught? I naught, if you put 0, it is going to be pi. So I naught is nothing but pi. So you can see in is irrational when n is even. Yes, perfect. It will come out to be pi. So these numbers are integers, these numbers are integer or rational numbers, you can say, multiplied to pi. So this will be an irrational number. Okay, so that is perfect. Now I2 and I4 you can calculate, them easily. So I2 you can calculate easily. I2 is nothing but I2 is if you put n is equal to 2 in this, I2 is using this 1 by 2 of I naught, right? And I naught is what? Pi. So pi by 2. So I2 is pi by 2. If you want to calculate I4, I4 is nothing but what? I4 is 3 by 4 into 1 by 2 I naught. So you can calculate this I4 also using this formula, using the same formula. N is even, because n is even in these two cases, I2 and I4. So this is going to be 3 pi, I naught is pi, divided by 8. 3 pi by 8, alright. Now you can add them. So I2 plus I4. If you add them, this pi will be common. This will be 7 pi by 8, okay? Yeah, so perfect. D is also correct option. D is also correct option. So D is also correct option. B is also correct option. The only C is remaining. So now we need to check it for n is equal to odd number. See what will happen when an n is odd. Let's do it here only. If n is odd, these number. If n is odd, then these numbers in numerator will be even, right? These are even numbers, so now it will end like this. Now I'm changing only last three numbers. Okay, so now it is going to be 4 upon 5, it is going to be 2 upon 3, and then I1. Okay, so I1, it will end at I1. So if it is ending at I1, what is I1? I1 is 0 to pi sine x. 0 to pi sine x is nothing but 2. This is 2. All right, so in this case it won't be pi, okay, not irrational. So now all these numbers are rational numbers. These numbers are rational number, and this is also a rational number, right? So when n is odd, answer is going to be rational. Sorry, so I raised by mistake, but I hope you understood it. Okay, now let's do this another example. This is again a very good example, and you can use. All right, so let's solve it. So if you apply in is equal to minus pi to pi sine of nx divided by 1 plus e raised to x sine x. So you can see this is similar example to what we have done in the beginning, sine nx upon sine x. The only thing is 1 plus e raised to x is there, right? So if you apply King's rule, a plus b minus x, so you can write minus pi to pi, a plus b is 0, so you can replace x by minus x. So it is going to be sine of minus nx divided by 1 plus e raised to minus x and sine of minus x, all right? So you can write I is equal to in is equal to, simplify this, so it is going to be minus pi to pi. This minus and this minus will come out and they will cancel each other, right? In numerator, this minus and this minus. And e raised to minus x can be written as 1 upon e raised to x. If you take LCM, it is going to be e raised to x sine nx divided by 1 plus e raised to x sine x, right? Now you can add this and this equation, right? First and two. So if you add them, then this 1 plus e raised to x will get cancelled, all right? So 2in is equal to minus pi to pi. If you add them, it is going to be sine x plus 1 upon e raised to x plus 1 upon e raised to x plus 1 sine nx upon sine x dx. And these two will cancel out each other. And you are going to get in is equal to 1 by 2 of 1 by 2 of minus pi to pi sine nx upon sine x dx. Now using the property, if you are applying King's rule in this, then this won't change. That means it is symmetric. It is symmetric about 0. It's an even function, so you can write 0 to pi 2 times. So this 2 will get cancelled and get in is equal to 0 to pi sine nx upon sine x. Now it's exactly the same problem which we have done, right? What was the reduction formula of this? Uh, Let me tell you. We have already done it. Here it is, right? So we were getting this in is equal to in minus 2, right? So we have done all the process. Let's directly apply here. So in is equal to in minus 2 and so on. It was when n is even, it was I2, then I naught when n is even, and I naught was nothing but 0, right? And when n is odd, it is in minus 2 and so on. I3, then I1, and I1 is nothing but pi. Okay, pi when n is odd. So this was the answer. Accordingly, you can answer this. So 1 to 20, if you want to add, then I sigma 1 to 20, then I1, I3, I5, I7, these values will be equal to pi. So 10 values will be odd and 10 will be even. So even values will be 0 and odd values will be equal to pi. Each value of k when k is odd, ik will be pi. So yes, it is 10 pi. So C is the correct answer. And let's check other options also. He's saying I1 is equal to I3. Yes, perfect. I2 is equal to I3. No, that is not true. Okay. I2 is not. I2 is 0. I3 is pi. So I hope it is clear. Now let's move to another example. So this is again a good question. You can do this using substitution or by parts. So try this one. Okay. Try this one. I'll discuss this after 2 minutes. All right, so let's just start this. In is equal to 0 to 1 dx upon 1 plus x square raised to n dx. Okay, so to apply by parts, you can write 1 into this, all right, or maybe 1 plus x square, you can write like this, 1 plus x square. But by writing this, you will get one problem. What? Because antiderivative of this function is tan inverse, and tan inverse will appear and that will create problems. So it's better to take 1 into this, all right. So if you take 1 into this and this, 0 to 1, it is going to be, wait a minute, it's applied by parts. You can put tan x is equal to tan theta, all right. So that is also another way of doing it, substitution. But I'm doing it without substitution. So x integral of 1x, and second function as it is 1 plus x square raised to n, and this is 0 to 1, right, minus the um, integral of 1 is x, and differentiation of this is n, minus n actually. So minus n upon 1 plus x square raised to n plus 1 into differentiation of x square is 2x, all right, dx. Yeah. If you put 1 and 0 in this, if you put 1, this is going to be 1 only, 1 by 2 raised to n. Yeah. And if you put 0, it is going to be 0. Okay. So if you put 1, it is going to be 1 upon 2 raised to n plus. What is this now? Let's see. Let's take 2n outside, and this is 0 to 1 x square. You add 1 and subtract 1 so that you can split it. Okay. 1 plus x square raised to n plus 1 dx. So by doing that, you will get in is equal to 1 upon 2 raised to n plus 2n times. Okay. Now if you divide, this first term is going to be 0 to 1 integral of 1 upon 1 plus x square raised to n, that is nothing but in. And the second term you are going to get is 0 to 1 1 upon x 1 plus x square raised to n plus 1, so that is in plus 1. Okay. So in is equal to, this is 1 upon 2 raised to n plus 2n up 2n into in minus 2n into in plus 1. All right. Now you can separate this 2n. So this will be, bring this 2n into in plus 1 to left hand side. So 2n in plus 1 is equal to, this is going to be 2n minus 1 into in plus 1 upon 2 raised to n. Okay. So that is the relation. That is the relation you are getting. So let's see. Yes, the exactly same relation is given in option A. So option A is the correct option. And then by putting the values of I1, I2, you can find I2 also. So how to find I2? You put n is equal to 1 in this. So if you put n is equal to 1 in this, I2, n is equal to 1, this is 2, I2 is equal to 2n minus, you're putting I is equal to, n is equal to 1. N is equal to 1. So if you put n is equal to 1, this is 1, I1 plus 1 upon 2. So what is I1? I1 you can find easily. I1 is basically tan inverse of x 0 to 1, and this is pi by 4. All right. So I1 is nothing but pi by 4. So I2 is pi by 8 plus 1 by 4. Okay. This is your I2. So yes, I2 is also correct. Similarly, you can find I3. Similarly, you can find that's it. I3 also you need to find. So you can find I3 also. I hope it is clear, this reduction formula. Now let's do the another one. Yeah. So this is again a very good question of reduction formula. It is, let me give you the hint. This is based, this reduction formula which we were using here, this will be used, sin x upon sin x will be used in this question also. Okay. So try this one, then I'll tell you. So it is similar to that, sin nx upon sin x. Try to find the value of UA. All right, so I'll do it then. Un is equal to 0 to pi by 2 sine square nx upon sine square, like the previous problem sin nx upon sin x, in which we took in minus 2 and subtracted with in. In this I'll take first I'll check un minus 1. I'll add and subtract with un. Then if it works, then fine. If it doesn't work, then I'll take un minus 2. So what is the main purpose? Purpose is to cancel this sine square, or to get a function which is integrable. All right. So if I take un minus 1, which is 0 to pi by 2 sine square of nx, n minus 1x, sine square of n minus 1x divided by sine square x dx, and subtract these two, un minus 1, then that is going to be 0 to pi by 2. It is going to be sine square a minus sine square b, so that is sine a plus b into sine a minus b. So sine of a plus b is nx plus n minus 1 into x. It is sine of a minus b, so that is nx minus n minus 1 into x divided by sine square x dx. All right, so now you can see this is nothing but sine x. All right, so this one sine x will get cancelled. And what is this? This is 0 to pi by 2 sine 2n minus 1 into x divided by sine x. So now you take this in separately, although we have done it. Take this as in is equal to 0 to pi by 2 sine of 2n minus 1 into x upon sine x, and write in minus 1 to get another reduction formula, because this is sine nx upon sine x type, although we know n is odd in this, so we might write the result directly, but let's do it again. 0 to pi by 2, it is going to be sine of 2n minus 3 divided by sine x dx. All right, then you subtract it. If you subtract it, it is going to be, although you can copy this result, let me tell you which result I'm talking about. See, here I was getting two things. When n is odd, I was getting answer as pi, right? And when n is even, answer was 0. So in this case, clearly you can see n is odd, right? N is odd, this one. N is odd in this, right? So clearly you can see that in going to be pi. It will come out to be pi, all right? If you want to use that result, you can use it here directly. So by using that result, I can write this is equal to pi. Otherwise, you can subtract these two, simplify. It will come out to be a constant. It will be 0, in minus 1. Then you keep reducing it and then calculate I1. I1 is going to be pi by 2. Okay, so that was basically up to, let me do the correction. Now, this was 0 to pi, and if you make it 0 to pi by 2, then result will be pi by 2, because you can see this is symmetric about pi by 2. Apply the King's rule in this. Apply the King's rule in this, pi minus x, and it will come out to be, if n is odd, it will come out to be symmetric about pi by 2. All right, it will remain same. So you can half the result. I mean, this result will be half pi by 2. Okay. Or if you want to do it, then do it. in minus 1 is coming out to be 0 to pi by 2. If I apply sin c minus sin d, it is cos of c plus d by 2. So that is 4n minus 4 by 2. So that is 2n minus 2. All right. Into sin c minus d by 2. So that is sin x upon sin x. Sin x will get cancelled. And integral of this between 0 to pi by 2. This is x. Okay. So integral of this between 0 to pi by 2 is coming out to be 0, because you can see 2 is there, 2 times of n minus 1. Okay, so 2 times of n minus sine of 2 times of n minus 1 will get, if you put pi by 2, it will become sine of integral multiple of pi, and sine 0 is 0. So this will be 0. Okay, calculated. So in is equal to in minus 1, and so on up to I1, which is nothing but 0 to pi by 2, and if you put 1, then it is sine x upon sine x, all right, which is coming out to be pi by 2. So that was I was talking about. This result is pi by 2, and we have got this un minus 1 is equal to pi by 2. This is the result finally. Okay, so U1, U2, U3 constitute an AP. Yes, this is perfect. And hence it otherwise find UN. So now you can find UN because now you can get U1, and U1 is what? U1 is what? U1 is pi by 2, right? Because this will become 1. This will become 1. So 0 to pi by 2, it is 1. You are integrating 1. All right. So U1 is pi by 2, common difference of AP is pi by 2, common difference D is pi by 2. So you can write UN is equal to A first term plus N minus 1 into D. D is pi by 2. So there is nothing but N into pi by 2. Okay. So this result U1 is pi by 2, U2 is pi 2 times of pi by 2, U3 is 3 times of pi by 2, U4 is 4 times of pi by 2, and so on. So generalize it. UN is N times of pi by 2. So this was a very, very good question. Okay, so we have done it. It's a similar question, we have done it. So you try it, do it fast. Okay, so perhaps you have done it. Let's do it then. 0 to infinity x raised to 2n plus 1 e raised to minus x square dx. So if first of all you should put x square is equal to t. So if you put x square is equal to t, this 2x dx will become dt. Okay, so make this 2 and divide by 2. So and take 1x out of this, 2x raised to 2n. So it will become 1 by 2 of this integral in. Let's write it in is equal to 0. So 0 will remain 0, infinity will remain infinity. I have changed the limits. Okay, so these are the new limits which are basically same as the previous one. Now this 2x dx will become dt. It will be e raised to minus t, and this is going to be t raised to n. X square x raised to 2n will become t raised to n, and we know the result of this. We have already done it, and if you want to do it again, you can do it. So apply the pi parts in this. In is equal to 1 by 2 of, if you apply the pi parts, it is going to be t raised to n as it is, e raised to minus t, 0 to infinity minus integral of n times of t raised to n minus 1 e raised to minus t plus 0 to infinity. All right, this dt, this will come out to be 0 because as I told you, e raised to t upon e raised to t when t is approaching to infinity is 0. All right, and if you put 0, it will be 0. So this limit will turn out to be 0, and in is equal to 1 by 2 of, and this is nothing but n times of in minus 1. All right. So this 2 will keep this. This is the result. In is equal to, wait a minute. Yeah. Let me check this 2. Yeah, 2 will be there. I think this 2 will be 2 raised to n should be there, because it is coming out to be n by 2. So, okay. So what you need to do is, because let's do one thing. Might be confusing in this way. So I'll do one thing. I'm taking this as a separate, say, an. Okay, so an is equal to, I'm taking this as an only this integral. Okay, leaving this 1 by 2. So it is going to be 0 to infinity t raised to n e raised to minus t dt. So you can directly use this result. An was nothing but n factorial. All right. So this you can leave this 2. Otherwise, you might get confused whether it is recurring or not. So now you can use this result. An is this an minus 1, and this is n into n minus 1 into n minus 2 into so on up to 1 into 2 into a1, and a1 is 1, so it is going to be n factorial. So an is nothing but n factorial. All right. So an is going to be n factorial. Then what is this in? In is nothing but 1 by 2 of an, and that is 1 by 2 of n factorial. Okay. That's 2 was not recurring. This is the answer. C is the answer. All right. So C is the answer. I hope it is clear. Okay. So using this way, you can just leave that constant and take this part integral t raised to n e raised to minus t as an, and then find an. You can find an. An is n factorial. We have already done that. Okay. So try this one. This one is a very good question. All right, so let me do it then. See how to do it. In is equal to 0 to pi by 2. Now, how do we start? To start, you can take 1 into this, or you can take one expression outside this n, like sine x plus cos x. So yes, it is advisable to take sine x plus cos x, 1 sine x plus cos x outside, and sine x plus cos x raised to n minus 1. Because if you integrate or differentiate this sine x plus cos x, it will come out to be sine x minus cos x or sine x plus cos x, right? So they will just keep interchanging. So in this way you can do it. You can integrate this, you can differentiate this, all right? So let's do it. This is 0 to pi by 2. Sorry, apply by parts. Now apply by parts. So if you apply the by parts, it is going to be sine x, sine, again, in short, I'm writing sine as S and cos as C. So sine plus cos raised to n minus 1 as it is. And now integrate this. So integration of sine is minus cos and integration of cos is sine. So it is sine minus cos, all right? This. And limits 0 to pi by 2 minus integral of 0 to pi by 2, this function as it is, sine minus cos, into differentiation of this is n minus 1 sine plus cos raised to n minus 2 into differentiation of sine plus cos, so that is cos minus sine, all right, cos minus sine dx. Now let's put the limits. If you put pi by 2, uh, so if you put pi by 2, so cos will be 0, cos will be 0, and you'll get 1 only. And if you put 0, then if you put 0, then sine will be 0, sine will be 0, and it is going to be uh, minus 1, 1 raised to n minus 1 and minus 1. So that is minus 1, so plus 2. So it is going to be 2, all right, 2. So 1 plus 1. So you'll get 2, okay? So if you put the limits, calculate it easily. It is coming out to be 2 minus 0 to pi by 2. Now let's simplify this. 0 to pi by 2. This is sine minus cos. This is cos minus sine. So you can write this sine minus cos. Plus, if you take minus sine common, it will be plus, and it is going to be sine minus cos the whole square, all right? And n minus 1 you can write outside or here into sine plus cos raised to n minus 2 dx. Now, is there any relation between sine minus cos and sine plus cos? Yes, there's a relation. What's the relation? If you start with this, sine plus cos the whole square, which is sine square plus cos square, plus 2 sine into cos, plus sine minus cos the whole square, which is again sine square plus cos square, minus 2 sine into cos is equal to 1, all right? Sorry, is equal to 2. Okay, because 2 sine into cos will cancel each other, and sine square plus cos square will become 1 in this, and sine square plus cos square will become 1 in this also. So 1 plus 1, 2. Okay, so that is a very simple relation. You must know it. Either expand it, you'll get it. Expand it if you're not getting. Expand these two, you'll get it. Sine square plus cos square will be 1 in this, and sine square plus cos square will become 1 in this. 1 plus 1 is 2, and the 2 sine AB, 2 sine into cos term will get cancelled. Okay. So obviously you can replace sine minus cos the whole square by 2 minus sine minus cos the whole square. So it is 2 plus n minus 1, 0 to pi by 2. You can write this sine minus cos as 2 minus sine plus cos the whole square into sine plus cos raised to n minus 2 dx, all right? So we are about to get the answer n minus 1. Now multiply this, so it is 2 times of this function, which is in minus 2, all right? So it is 2 times of in minus 2. I'm writing it directly, minus. To multiply this and this, it is sine plus cos raised to n, and that will become in only, right? Yes. So just now, just you need to separate it. So n minus 1 in, this is n minus 1 in, and if you bring it to left hand side, it will become n times of in is equal to 2 plus 2 times of n minus 1 in minus 2, all right? So that is what happens. Okay. So this is the reduction formula. What you need? You need this. N minus 2 times of n minus 1 in minus 2 You need this value, and this value is nothing but 2. Okay, so answer is 2. So you needed this value, and answer is equal to 2. I hope it is clear. Okay, so this is again a very good question. Sine x upon x 0 to infinity is given as I, and you need to integrate this 0 to infinity sine x plus sine into cos bx upon x. You need to find this in terms of I. Although there's no reduction formula to be used in this, it's a simple substitution based question. So let's do it. Getting anything? Okay, then let me do it. So if I start with this 0 to infinity sine of ax into cos of bx upon x dx. So you can apply 2 sine a cos b formula in this. So you need to multiply and divide by 2. So using that, this is say I1, okay, I1. So 2 sine a cos b is what? 2 sine a cos b is sine of a plus b, that is a plus b into x, plus sine of a minus b, so that is sine of a minus b into x, divided by 2x, divided by 2x. What am I going to do is I'm going to separate these two integrals, all right? 0 to infinity, 0 to infinity. In this you can put, see, this should be your theta, so that you can compare it with sine x upon x. So put a plus b into x is equal to t, all right? And in this put a plus a minus b, so whatever this angle is, put that angle is equal to t. So in the second one, put a minus b into x is equal to t, all right? Now let's see what happens. So this will be dx is equal to dt upon a plus b, all right? So here integration will become I1 is equal to, if you substitute, this is 0 to infinity, this this will become sine of t, and if you replace this x by t upon a plus b will come here, and dt upon a plus b, all right? So eventually a plus b will get cancelled. Similarly here also the same thing is going to happen. It is sine of t upon 2t upon a minus b, and it will be a minus b in place of a plus b, and dt upon a minus b, and limits will remain same, okay? A is greater than b, so a is greater than b, So in this case also you can see when x is approaching to infinity, t will approach to infinity only. So limits are going to be same. When x is 0, t will be 0. So this I1, you are getting I1 is equal to 1 by 2 of 0 to infinity sine of t upon t, right? And the second one is also 1 by 2 of 0 to infinity sine of t upon t only, dt. So this is your I, this is your I, so it is 1 by 2 of I plus 1 by 2 of I, so this is nothing but I. It's I1. The integral which we needed to find is nothing but equal to given integral. Both are same. I hope you got it. So we have a similar question, so based on that only, it's a comprehension. So this is the second part. In this also, it is given that 0 to infinity sine x upon x is equal to I. Okay. So like you did the previous one, you need to do this also. Okay, so try this one. Take this as I1 and start. I1 is equal to, like in the previous question I have taken sine square x upon x square dx. Start with this. All right, so let's finish it then. So this is our last problem as well. So I1 is equal to this. We'll take you need to express this in terms of sine x upon x. Think about it, what to do. What are you doing in this? Can you apply by parts? Yes, you can apply by parts. If you write it like this, 0 to infinity sine square x, you can differentiate this and you can integrate this 1 upon x square dx. Or you can differentiate this or you can integrate this, alright? But how to integrate sine square? To integrate sine square, you need to write it in terms of wait a minute. So we can write the integration of sine square separately. Sine square x dx is basically 1 minus cos 2x by 2, all right? Integral of this, and then that is 1 by 2 of x minus sine 2x by, it will become 4, all right? So that is the integral of sine square x, 1 by 2 of x minus sine 2x by 4, all right? Okay. So you can use this integration. So let's apply the by parts. After applying the by parts, it is going to be sine square 1 upon x 1 upon x square as it is, and if you no, I'm sorry, you need to integrate 1 upon x square so that it will become 1 upon x, because power will reduce. If you differentiate 1 upon x square, it will become 1 upon x cube. So that will be a problematic. So it's differentiation of sine square and integration of this. Then that will be easier also to integrate this and to differentiate this. To differentiate this and to integrate this. Alright, so what this is sine square x as it is, then integrate 1 upon x square, so that is minus 1 upon x, okay? Integration of 1 upon x square is minus 1 upon x, 0 to infinity, minus integral of differentiation of sine square is 2 sine x cos x, into integral is minus 1 upon x, so put minus plus here, and then x and 0 to infinity. If you put infinity or 0, this is going to be 0, alright? If you put infinity, then numerator is sine square, it will always be between 0 and 1, and dividing by infinity, it will become 0. And if you put 0, this is sine, you can find the limit, sine x into sine x divided by x, this is 1, and this is 0, alright? Limit. So it is coming out to be 0. So now only thing remaining is 0 to infinity. You can write this 2 sine x cos x as sine 2x dx divided by x, alright, like this. Now this is a similar problem which you did in the here only, sine of like see this one, this was sine of a plus bx upon 2x was nothing but I by 2, right? It turned out to be I by 2. Okay, you do it. You put 2x is equal to t, then dx will be dt, and this I1 is going to be 0 to infinity only, limits will remain same. This will become sine t, and this will become t by 2, and this will become dt by 2. So 2 and 2 will get cancelled, and this is nothing but 0 to infinity sine t upon t dt, which is nothing but I. So I1 is coming out to be I again, okay? So in this case, answer is D option. So D is the correct answer. Okay, so I hope it is clear. Now rest of the definite integration we'll do later. I have another session at 3 o'clock. Let's see how many problems are remaining. One more problem is remaining. Okay, so we'll do another session on functions in next class, 3 o'clock. Till then, take care. Alright, thank you very much. Like and subscribe the channel, like my videos, and use Jeet1 if you are subscribing Unacademy Plus.